Hello, we are going to learn about commutative properties and addition and multiplication, and associative properties too. We're going to simplify expressions by combining like terms, identify coefficients of terms. We're going to use journal pages 189 to 194. So let's get started on page 189 and start talking about some vocabulary and thinking about this. So we see on page 189, sorry, there's two vocabulary terms about properties. So properties are rules that occur in math that you can count on, and it gives you shortcuts, especially in algebra. So in the vocabulary box, we see associative property of addition. Now, associative reminds me of the word associate. Have you ever heard of the expression, you are thought of, or you have the reputation of the friends you associate with or you are with? So that kind of reminds me of that word. And then commutative property of addition. Nothing really comes to mind offhand, but let's take a look at the examples and talk about this. So we see this in an expression or diagram. So this is just a visual model to help us think about this. So remember, equivalent means the same or equal. So you might see a fraction like 1/2 that's equivalent to 2/4. They both have different numbers, but they're the same value. So here we see Joey and a diagram next to Joey, and we see an unknown amount for A, which is larger than B. But over here it says A plus B is this equivalent expression, or what that represents. And then we have Ariana. She has a B and an A, and hers look to be flip-flopped. So her equivalent expression to Joey, so these are both the same, is showing us that A plus B is going to be equivalent or equal to B plus A. They both are going to have the same value. So if you think about this in the real world, you could say that Joey earned $A in the morning. So maybe the A and the B represent time periods, and $B in the afternoon, whereas Ariana earned $B in the morning and $A in the afternoon. So we could say A means 50 and B means 25. If Joey earned $50 in the morning and another $25 in the afternoon, to find out the total or the sum, you'd combine them and get 75. Same thing with Ariana, but we would say she earned 25 in the morning and 50 in the afternoon. So that's what that means. Let's go to the next example here. And then also it says the bars are the same length and the expressions are equivalent. So now let's look at the associative property. Up above, we just looked at the commutative. You can rearrange them and still have the same amount. In fact, down on the bottom of the page, they're highlighted. Here's example 2. Here we see 2 bars that are the exact same amounts for Claire and Mateo. Here they are written as expressions though, right? So we could say that A plus B, and here you see that, I want to call it a bracket, but A plus B plus C would give us a total for this combined amount, and then Mateo's is represented with A plus B plus C. So if you combine B and C together, those are in parentheses, and it just shows you that they're both the same value. They're equivalent. So then down below it just says, the examples above illustrate 2 important properties of addition. The commutative property of addition. For any numbers, A and B, A plus B is equivalent to or the same as B plus A. For example, 5 plus 2 is equivalent to 2 plus 5. It doesn't matter what order you add them in, you get the same results. And then the associative property of addition tells us that for any numbers, for example, A, B, and C, A plus B together added to C is going to be equivalent or equal to A plus the result of B plus C. They're all addition, so it's going to give you the same total. For example, if you substitute A with 3 and B for 4, 3 and 4 plus 7 is 8. It's going to be the same as adding the 4 and 1 here with the 3. So that's that.